Welcome to our new RealVirtual.io tutorial. In this tutorial, I'm going to show you how to use sensors and how they interact with colliders. This special issue is in a lot of cases a problem in our support cases, and so I think it makes sense to take a deeper look into that matter. For this tutorial, I prepared a simple setup. This setup, I'm having a cube, so a simple 3D cube in the scene, and I attached to this cube a drive. The cube is having a box collider, and the drive is controlled by a drive cylinder behavior model with a max position of 2000 millimeters. And it's controlled, it's a 1-bit cylinder, and it's controlled by one signal, by a PLC output bool. So I can, by forcing the signal back and forth, I can move the cylinder, so the non-visible cylinder, which is controlling this cube, out and in. So that's currently our demo setup, and based on that I'm going to explain you some basics about sensors and colliders. First of all, I want to add a sensor to my scene. For doing this, I'm creating an empty game object and adding a sensor here to this game object, and let's call it sensor. You already see this yellow line here in our sensor. So that's the sensor direction, and we can change the direction by changing here the raycast direction, or we just rotate it. So I'm going to rotate it, and I would like to have the sensor, like it has been before. I'm going to place it here. And let's make the sensor longer. So the standard measures within RealVirtual are always millimeters, whereas this bottom grid and the units in Unity itself are always meters. So let's extend the sensor for 3000 millimeters. So it has a height of 0.2 meters or 200 millimeters, so it should collide with a box. For sensors, for raycast sensors, that's one option for sensor and usually our recommended option. You could also use colliders as sensors, but usually, because it's better in the performance, you should use raycast sensors. So for raycast sensors, they're always raycasting on the layer where they are located. So currently here on the layer default. So let's, for the moment, delete this additional raycast layers. So we are just raycasting on the layer default. So let's see what's happening. By turning this blue cube, this cube going in and out, the sensor is getting into a collision with our cube, the raycast sensor, and we see that it's getting high by this change in the color because it's getting red. Okay. But usually in RealVirtual we don't use the standard layers because we are having special layers which are controlled for collision against each other, and we limit the collision detections to certain layers or between certain layers, because in very huge models that has a high impact on the performance. And we can also prevent collisions which we maybe don't want to have. So a sensor usually should raycast on the layers which are used by MUs. And these are these two layers, so the layer sensor MU and MU. So let's take first the layer MU, and we can add here in the additional layer, for example, our layer G for a sensor MU. I think it's called sensor MU. It's written like that. So if we are now checking again, we'll see that our sensor is not getting high anymore. And that's because our cube is still on the standard layer, but all our movable units, usually they have core layers, they have a layer assigned which is at least G4A MU. So that's the generic layer of movable units, which is colliding against sensors and which is also colliding against the environment. So let's see what's happening now. Yeah, our sensor is detecting it. Another way for defining sensors is by using colliders as sensors. So I'm generating a second sensor just by duplicating this one. Let's call it sensor collider. And for this sensor, we would need to have a box collider. So let's make it, I know we'll do it like that. We put the sensor on this cube here. So where's our cube? We should move it to 0, 0, 0. We don't need this one. Even this. So that's our sensor collider. And for a collider sensor, we always need a box collider attached to it. And for not using the raycast, we are turning this off. And now automatically he is not using a raycast, he's using this box collider as the sensor surface. And you see we don't see any raycast anymore. So let's give it maybe a length of 3 and 0.05, 0.05. So also like a ray in this direction. With these sensors, or let's keep the sensor like that and just check what will be the case. So as you can see, our sensor based on a box collide is not detected. And that's because our sensor is still on the layer default, but in this case it should be on the layer sensor. The layer G4A sensor is a layer where all our, I would say, mesh or form-based sensors should be located to, and this layer is going to detect our MUs. So by moving it now out and in, we'll see that the sensor is working as expected. So to summarize, you could use raycasts or colliders as sensor components. We usually strongly recommend to use raycasts because they are better in performance. If you're using collider-based sensors, please always use box colliders. Using mesh colliders, especially against other mesh colliders, could create flickering sensors due to limitations in the physics engine. So that's also the case why raycast-based sensors are preferable in most cases. What about collisions between parts? So maybe we move this sensors a little bit to the right hand side, and I'm generating here a new component, so a 3D object, a cube. And with this cube, putting it here, 0.5, no, 3, 0.2, 0.2. So let's assume that that's something which is laying on the bottom. If we now just start it, so let's place it here, a little bit up, and let's give it a color. In our materials, so maybe classic green. Now starting it, nothing happens. And that's because this green component is currently, so our, let's call it collider cube, is having a box collider, but it's not having any kind of rigid body, which gives it under control of physics law. So I'm adding here a rigid body. Is using gravity. When we are now turning it on, you'll see that our green collider is falling through and moving until forever. And that's because our collider is on the layer default. And all our things, our transport service and all our components are usually, so everything which is moving around and should collide should be on the layer G4A MU or G4A transport MU. The difference between MU, which we have been using before, and transport MU is that the MU layer is colliding with transport surface and surroundings, whereas the MU collider, the difference is that the MU collider is colliding with transport surfaces and sensors, whereas the sensor MU collider, which might also be used in MU, is only colliding with sensors and not with surroundings, for example, transport services. So let's place this component on the transport layer. No. So let's place this component on the MU layer, which is usually used by movable components. And as we can see, it's falling on the bottom. And by moving the cube out and in, we can move it around. So let's restart it. So basically our cube, which is on the layer MU, is colliding with this collider cube, which is also on the layer MU. And we are able to push it for falling down. What happens if we put this on the layer transport? If we put it on the layer transport, it's also colliding with the bottom, and same thing, we also can move it by pushing out this cube. So to summarize, always take care where you place your sensors and your movable units. For example, if I place this collider cube here on the default layer, it will fall through the bottom. So if you see something falling through, usually it's on the wrong layer. So everything which is colliding should be on the layer G4A MU for MU or on the layer G4A transport. This will collide, and it will also collide with other MUs. It's the same thing for sensors. Always take care on which layers a raycast sensor is raycasting. It's raycasting on the layer where it is and on additional raycast layers. And if you would like to detect MUs, you should at least raycast on the layer MU and maybe also on the layer sensor MU. That depends a little bit on the configuration of your MUs. For being sure, you could always use both MUs. And they will be able to detect movable units like we used here on this cube. There's one very special layer, and I will show it here. If we are using our layer sensor MU, that's a special layer for sensor detection, which should be used on MUs. As you can see, it will fall through our bottom. And that's because this layer is not colliding with surroundings, transport surface, and so on. It can be used on MUs just for being used for detection by sensors. But usually on MUs, you should always use the layer MU, which is on one hand side colliding with the surroundings and transport surface, and on other hand side, it's also detected by sensors. So if something is not working as expected, please always check your layers and your collision settings. The standard collision settings in the projects are set here. It's in the physics settings. We are having here a collision matrix, which is defining exactly which layer is colliding against which other layer. And all these G4A standard layers, that's the standard configuration and definition. Just in case if you don't have these layers or mix something here, what you usually should not do, by selecting a game for automation, apply standard settings. Where is it? Apply standard settings, yes. If I'm now going back into my project settings, I'm having the standard configuration again. So in most cases, if you're not an expert, and for all our projects we are doing, we never change something in here on the layer settings. So far used our standard raycast sensor here. As I mentioned before, usually you should not use collider-based sensors. There's also one additional sensor. Let's call it Measure. That's also how it is called. You can add it here by add component Measure. I know on this I would like to measure raycast, this component, and that's generating a raycast into a certain direction, and we can also turn it in this direction, for example. Here it is. And same thing, we need to define the layer, so let's raycast on the layer MU. just need to place it on the position where it should be. And you directly see here in the tooltip that it's measuring a distance. So let's make it maybe longer. So, and by now turning it on, you will see that as long as our component is within the distance, we are measuring the distance, and the distance is measured based on the pivot point where our raycast is attached to. And you can attach also here or connect it with signals, so you could give back this measurement back to the PLC. So that's our MeasureRaycast. There's also one additional sensor. If we add here the component measure, we can measure the distance from this component here to a certain other component. Let's select, for example, our cube. So we're getting here a distance in all coordinates between our pivot point here and the pivot point of our component. So we are having here a measurement, and by moving the cube, the measurement will also change. And this distance, the absolute distance and the distance in the coordinate system, could be also connected to PLC inputs for using it, for example, for virtual commissioning. That's all for this tutorial. Maybe not so nice 3D components and movements, but the layer and sensor system is something very important. And in a lot of support cases, the issue is just that the layers are not defined on the components as they should be. So if things are not colliding, please always take care about the layer settings on your movable components, on your transport surfaces, and on your sensors. Thanks a lot for this tutorial, and see you in our next tutorial. Bye bye.